Blockchain. We hear it everywhere. In the news, on the internet, we can't escape it. Blockchain, Bitcoin, Ethereum, smart contracts, ICOs, distributed ledger technology. It is a bewildering array of new vocabulary that have entered our lexicon just in the last year. And to be honest, we have no idea what it means. And it's not just confusing, but it's big. In the last 14 months alone, almost $6 billion in funds have flowed into blockchain startups or connected startups globally. The Gartner Group estimates that by 2025, the business value add from blockchain will exceed $176 billion globally. If the blockchain economy were a standalone economy, it would be the 55th biggest in the world, bigger than Algeria. And that number is estimated to exceed $3.1 trillion by 2030. That is 50% larger than the US economy is today. So how is a technology this momentous still so confusing to the great many of us here? And I'm being presumptuous. I'm assuming that many of us still scratch our heads over blockchain technology. And the reason why I know this is because it is a very, very innovative technology, not just in terms of the way you think about it, but on the technology that it lies on. Blockchain lies on very advanced, powerful cryptographic technologies. So a complete understanding and explanation of blockchain will take more time than you have today and someone much smarter than I am to explain it to you. But I think what we're going to try to do here today is to at least let you walk out of the door having a much clearer understanding of what blockchain is, why it's so powerful, and what we can do with it in our lives, not just in financial services, but across a variety of different industries. So even if you don't walk out here as cryptographic experts and blockchain developers, hopefully you could sit and watch the news and read an article about blockchain or sit at a business cocktail party and talk intelligently about blockchain and how it applies to our daily lives. So I think what we'll do is we'll start with the question that we asked from the very beginning is, what is blockchain? And I think one of the fair comments is that there seems to be no fairly common universal definition of blockchain. You know, you ask 10 different people what is blockchain, you will get 10 very different answers. And my view is that trying to describe blockchain is like trying to describe a piece of art. We're all looking at the same thing, but we all interpret it slightly differently. So I'm going to share with you what I think is probably the most concise, most self-explanatory definition of what blockchain is. And that is this. Blockchain is a ledger that records a chain of data blocks. A ledger that records a chain of data blocks. Now, you're probably sitting there thinking two things. One, what the hell does that mean? And two, a ledger? My accountant keeps a ledger. What is so special about a ledger? Well, that is what the rest of this session is about. It's not just a paper ledger we're recording numbers or items or any type of database that you might keep on your computer. Again, there are cryptographic technologies, advanced mathematics that underlie blockchain that imbue this technology with certain features that make it so revolutionary. So revolutionary that many in the industry hail it as the next stage in the evolution of the internet, like the Internet 2.0. So why don't we start with talking about some of those characteristics that mark blockchain and what makes it unique. We'll start by saying that blockchains are distributed. And again, what does that mean? We know what the word distributed means. What does it mean in the context of blockchain? What it means in this context is that all participants in a blockchain network have an identical copy of that ledger, meaning that all people have access to all the same information. There's information symmetry. Now let me take a step back and build up to that explanation again. If we think about the way information has traditionally been organized throughout pretty much most of humanity and maybe the early stages of information technology, much information was highly centralized. Data was kept in single points of control or very, very few points of control. There were single point hubs that other participants would access through that central repository. So usually that central point of information was a trusted source of information, whether it was a trusted storehouse of that information. Whether it might be the government, it might be your hospital, it might be your bank. Then, as the information age took off, we saw that the internet unlocked the possibility of decentralized information networks, where now we can start moving information out to different points of the periphery. And we saw this even accelerate during the cloud era, so that there were no single points of failure or attack. You could distribute information broadly, and nodes basically can access and reach different points of participation. Now, what makes blockchain quite interesting is taking all those decentralized points and interconnecting all of them so that there is linkages, much like a spider web. And so when you hear the term distributed ledger technology, most people use that interchangeably with blockchain, because that is what blockchain is that it basically relies on the power of decentralized networks that have been basically bound together through this web. Another key characteristic of blockchain is that it's consensus-driven. So let me go back to that definition of blockchain as a chain of data blocks. In a blockchain network, when you want to add data to a ledger, data gets grouped into blocks, which are then validated before added to the blockchain. And by validated, it's mean as verified as true and accurate, and then added to the ledger. So consensus-driven means that if you have multiple participants on a blockchain network, all with access to the same ledger, then it will take a majority of those participants to validate information that gets added to that ledger. So it is a group participation model. It's really a network that is utilizing the wisdom of crowds. And then another key feature that builds on the first two is that blockchains are immutable. Records on the blockchain are immutable. And that means that records cannot be altered, cannot be destroyed, cannot be corrupted. And this is quite important because we're building up to a network that requires group consensus, cannot be altered, everyone has access to a single point of information. So we're creating transparency in the blockchain network. Now, if you think about my previous point about consensus-driven, the first question you might ask is, okay, if it only takes a simple majority to alter or influence a blockchain, doesn't that make a blockchain less secure? Theoretically, yes. But if you think about the scale of public blockchains today, so let's use Bitcoin as an example. There are over 12,000 Bitcoin nodes scattered around the world today. Actually, about 50 here in Thailand. If you look at Ethereum, there are 19,000 nodes. around the world. So in order to be able to hack 51% of any of those nodes would require someone to have access to probably about 500 of the world's most powerful supercomputers at once. So the type of information you'd want to hack probably isn't worth the cost and time it would take to hack all those nodes. And the blockchain is auditable. So all data that gets added to the blockchain is time-stamped. So now you've created a chain of data blocks that where each block of data is time-stamped, has been validated by the majority of nodes on a network, and is immutable and inalterable. You are creating a ledger that cannot be corrupted, that cannot be violated, cannot be altered, is fully auditable. That is why blockchain is more powerful than simply your bookkeeper's ledger. What's also quite amazing about blockchain are the other types of functions that it's enabled. One of the most notable are smart contracts. And smart contracts are simply contracts, self-executing contracts that are built into lines of code in a blockchain. So if you imagine a network that could be imbued with digital if-then statements that automatically execute contracts upon fulfillment, we're talking about an incredible degree of automation and an incredible reduction in manual work and reconciliation. We're talking about the removal of intermediaries. And when you remove human intermediaries, you remove errors, you remove inconsistencies, you even remove fraud and bad behavior. So let's talk about some of the different ways that you can use the blockchain. So what my team and I have tried to do is we've basically scoured the entire universe of blockchain, and we'll tell you there are an infinite number of ways of using the blockchain. The use cases of using the blockchain are really only limited by the human imagination. And so what we tried to do to simplify this in the context of a 30-minute keynote is to basically group a sample of them into 3 broad use cases, and we'll go into a few of them. So the first one I want to go into is digital identity. And when people first thought of blockchain, they first saw blockchain as a fintech application, that this was strictly a technology for financial services. And one of the earliest use cases that people came up with, particularly around digital identity, is Know Your Customer, KYC. And I'm sure there are not that many people here who haven't tried to open up a bank account and who have suffered the experience of KYC, having to gather all their documents, their birth certificates, their housing registrations, all to open up a bank account, and you think, whew, that was done. And then you have to open up a small business account or a corporate account or another account, and then you have to go through the process all over again, because the information you've provided to one bank doesn't port over to the other bank. Sometimes it doesn't even port over to a different department in the same bank. Now imagine if all the information about you and your identity that you've supplied now sits on the blockchain. It's been added to the blockchain, it's been validated by the public network or private network, if the case may be, and then accessible by banks that you authorize on a select basis. That will save a great deal of time and money for both you and the bank. So KYC, one great example in the financial services space. We can look at digital identity in the medical space, in healthcare. Healthcare where hospitals have reams and reams of records of patient data, oftentimes unconsolidated in different departments and in different areas, sometimes in different hospitals. In a situation where security and privacy are paramount, having a secure network like blockchain becomes all the more important. Having a ledger that renders all the different sources of information into one single source that's highly consistent can mean the matter of a life or death situation in a medical room. We could look at digital identity in the voting and governance space. So the idea of having a single ledger, a single source of truth, allows us to reduce the possibility of fraud and double counting. This not only applies to voting, this can apply to the provision of government resources, such as welfare or social security and other government services. Estonia is actually one of the first governments around the world to look at e-voting. They have an iVoting scheme which was in place since 2006, prior to the blockchain, but other countries around the world have since started looking at blockchain-driven voting systems. Another category of use case is what we call value allocation and transfer. So if you think about a particular pool of assets, how can you easily track usage and then compensate asset owners for that usage if that usage is widely distributed? You could do it with the blockchain. So for one example, if you think about a television studio where a phenomenal amount of media equipment needs to be rented frequently and sometimes on a short-term basis, you're talking a phenomenal amount of paperwork trying to track the usage, rental rates, and the manual reconciliation involved in trying to settle that type of business. With the blockchain, you can automate and eliminate manual reconciliation. We can apply similar thinking to the energy sector. Blockchain is now enabling peer-to-peer energy trading by aggregating microgrids into virtual power plants. Blockchain now allows us to employ smart meters to accurately track usage of electricity, as well as create standards around micropayments that allow us to reduce costs of energy trading. There is a borough in Brooklyn, New York, a couple of years ago that allowed residents to install solar panels on the top of their apartment building and then trade the excess energy that they generated to their neighbors, all on the blockchain. This is happening. Another area of value allocation and transfer is in music streaming. So if anyone has moved over to music streaming services like Spotify, that actually required a monumental shift in thinking from owning your music to renting your music. But just as monumental is the shift in thinking from the relationship between the studio side and the producers. How do you compensate recording artists in music streaming? It's an incredibly challenging task to record and measure usage and properly compensate. But companies like Spotify have actually acquired blockchain startups, including MediaChain Labs, to look at the possibility of issuing tokens that basically compensate recording artists every time one of their songs gets listened to from a subscriber. A third area for blockchain applications is provenance. And provenance refers to the chronology of ownership or custody. So basically tracking ownership as it goes from owner to owner or custodian to custodian. And one great example of this is a collaboration between Nestle, Unilever, and IBM to create blockchain networks to track food as it travels in the supply chain from farm to consumer. And what this enables is that it allows us to enhance food safety and reduce food fraud. So imagine at the next E. coli outbreak, we can use blockchain to trace the source of contaminated food back to the food processing plant, or even back to the farm where that food originated from. We can use provenance for land registry and property ownership. So if you recall the earthquake in Haiti a couple of years ago, and the big scandal around Red Cross and the missing $500 million in donations, and the fact that only 6 houses got built, that was actually a situation that blockchain could have helped. The earthquake in Haiti, most people focused on the lost donations, and they only wondered why 6 houses got built. What most people didn't realize is that most of the land records in Haiti were kept on paper in municipal offices that were all destroyed in the earthquake. So even if you wanted to rebuild someone's house, the minute you tried to, there would be conflicting claims of ownership on any given land plot. So imagine if we had a fully running blockchain system a couple of years ago that could not only track land ownership, but also accurately track the proper usage of funds donated to Haiti. That would be quite amazing. Today, the Indian province of Andhra Pradesh is working with both Indian and Swedish blockchain companies to digitize over 100,000 land records and put those records on the blockchain. And several neighboring provinces in India are following suit. And then looking at provenance for high-value items, luxury items. Ensuring the authenticity and fighting fraud in high-value luxury goods is of paramount concern to this industry. Counterfeit goods is crippling this industry. So being able to track the ownership of pieces of art, being able to track the provenance of that Birkin bag, being able to ensure that those diamonds aren't blood diamonds, have long been a problem in this industry that blockchain can help resolve, or at least alleviate. Today, Deloitte is developing a blockchain network to track the provenance of high-value art. Now, I'm down to my last few minutes, and I've spent most of the time talking about blockchain, but I would be remiss if I didn't actually spend a few minutes talking about cryptocurrencies and ICOs before we left. The theme of this session is not about crypto, it's not necessarily about ICOs, but they're closely intertwined in the world of blockchain, and it needs to be discussed. If I had to put crypto and ICOs in its most simplest form, for those that don't quite understand the concept, if you think about what IPOs are to stocks, IPOs are a way of companies to issue new equity. ICOs are the way for blockchain companies to issue new tokens. And tokens, in a way, are some of the fuel that power blockchains. So if you want to know the relationship between, and when I say token, I use token interchangeably with cryptocurrency. So the relationship between a cryptocurrency and a blockchain is that if a blockchain if it's the roads and highways, then the cryptocurrencies are the cars that run on them. And cryptocurrencies is a very broad term. It includes things like Bitcoin, Ethereum, to some extent Ripple. We'll talk about Ripple's XRP. Litecoin, Dogcoin. There's over 1,500 tokens in existence right now. Tokens basically occupy multiple functions, which may or may not include as currency. They can have certain utilities, they can have certain functions. The interesting thing about tokens is that you can embed them with smart contracts, so that in the end, probably the best way to define a cryptocurrency is that it is a digital asset or a digital tool. A tool to do what? Again, almost anything that you want the blockchain to enable. Now, if we talk about the value of these tokens, there's a lot of interest in them because the value of cryptocurrencies have gone up quite dramatically lately. As of maybe a week ago or late last week, the total value of all cryptocurrencies in existence was about $380 billion US, about half of that Bitcoin. That sounds like a lot. To put it in perspective, the value of all fiat currency in circulation right now is about 5 trillion. So not quite there yet, but growing quite rapidly. So I hope that before we go into a more deeper dive with my fireside with Brad and then the upcoming panel with Dr. Boom, Val, and David, that you have a little better idea of what you're going to get into over the next 2 hours or so. Thank you very much.